Hi student, welcome to my channel Education Shop. In this video, solve problem 11.72 from the book Heat and Mass Transfer by Essential 6th edition. Here is a statement of the problem 72. A shell and tube heat exchanger with 2 shell passes and 12 tube passes is used to heat water whose Cp value is for 4180 joule per kg Kelvin. Here you can see the number of shell passes is 2. 4 tube passes is only shown in this diagram, but it is the portion of the heat exchanger, not the whole heat exchangers. But our study is under 2 shell passes and 12 tube passes heat exchanger. The Cp value of the cooled fluid that is heated from 20 centigrade to 70 centigrade at a rate of 4.5 kg per second. Let me write first the data till this point. The number of tube in the heat exchanger is 12. The Cp value of the cooled fluid is 4180 joule per kg Kelvin, but we need to convert that into kilojoule. So we will divide it with 1000 and you will get the Cp of the cooled fluid, that is 4.18 kilojoule per kg Kelvin. Inlet temperatures of the cooled fluid is 20 centigrade. After heat absorbed by this cooled fluid, the outlet temperature of the cooled fluid increases up to 70 centigrade. The mass flow rate of the cooled fluid is 4.5 kg per second. Now let me write the data for the hot fluid. The Cp value for the hot fluid is 2300 joule per kg Kelvin. But we need to convert that 2300 joule per kg Kelvin into kilojoule per kg Kelvin. You need to divide it by 1000 and it will give you 2.3 kilojoule per kg Kelvin. The hot fluid enters at the shell side at the temperatures of 170 centigrade. The T hot in is 170 centigrade. The T cooled out, the T hot out. The T hot out temperature is not given in the statement. Here you can see it does not exist. The mass flow rate of the hot fluid is 10 kg per second. The overall heat transfer coefficient is 350 watt per meter square dot Kelvin. Determine the heat transfer surface area on the tube side. You need to find the surface area of the tube. Now come toward its solution. First we will find the capacity rate of the hot and cool fluid, that is equal to m dot h Cph. M dot h is for the hot fluid is 10 and Cph of the hot fluid is for the hot fluid, that is 2.3. and you multiply this with each other, you will get 23 kilowatt per Kelvin. Similarly, this capacity rate for cooled fluid is equal to m dot c and Cp, that is the mass flow rate of the cooled fluid is 4.5 and heat capacity is 4.18. When you multiply, you will get 18.81 kilowatt per Kelvin. The heat transfer in the heat exchanger is equal to capacity rate of the cooled fluid and change in temperatures of the cooled fluid, that is T cooled out minus T cooled in. The Cc value is 18.81. T cooled out is 70 minus 20. You solve this on calculator and it will give you the rate of heat transfer in the heat exchanger, that is 940.5 kilowatt. We also noted the amount of heat transfer rate is equal to capacity rate of the hot fluid T hot in minus T hot out. The hot temperature out is not given. Divide both sides by capacity rate of the hot fluid. So we'll cancel all this. We are interested to find this value. So shift this into the left hand side and this to the right hand side of the equation. Then we can say that T hot out is equal to T hot in minus Q dot divided by capacity rate of the hot fluid. T hot in is 170 minus Q dot is 940.5. Capacity rate of the hot fluid is 23. Solve this on calculators and it will give you the hot temperature out, that is 129 centigrade. Now delta T1 is equal to T hot in minus T hot T cooled out. T hot in is 170 minus cooled out is 70, that is 100 centigrade. Then delta T2 is equal to T hot out minus T cooled in, that is equal to 129 minus 20 and it is equal to 109 centigrade. We are interested to find log mean temperature difference, that is equal to delta T1 minus delta T2 divided by ln delta T1 divided by delta T2. Just put the value and solve on the calculator. 100 minus 109 ln 100 divided by 109. Just solve this on calculators and it will give you the log mean temperature difference, that is 104.4 centigrade. We also know that Q dot is equal to A surface area U log mean temperature difference. We are interested to find this value. Divide both sides U and LMTD. This will cancel out with each other, and we can say that the surface area is equal to Q dot divided by U and LMTD. Q dot is 940.5 kilowatt. This kilo means 10 to the power 3 watt, divided by the U value is 350. LMTD is 104.4. Simply solve this on calculator and you will obtain the surface area for this tube of the heat exchanger, that is 25.7 meter square. I hope you understand. If still there is any confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed yet. Thank you so much.